Hi to all the students. I am pretty much sure that you would be able to hear me, right? So we will be starting up this class. You should share this session amongst your friends. And why you should do that? Because ultimately this particular series that I'm going to start, this is starting from today itself, I am bringing for those students who has already, who are already taking up classes in their school, and they actually say that the school has started organic chemistry first and not the physical or the inorganic chemistry. And this is where I am going to be doing up each and every chapter either in one shot or two shot. In today's class we are going to be looking at, I'll tell you, if you do not want to learn these topics, you can skip this video, but if you want to, this is going to be your one-stop solution. So we are going to talk about carbocation, carbanion. We're going to talk about inductive effects, different groups which are based upon which provides better inductive effect, minus I plus I effects, resonance, hyperconjugation, aromaticity. These are all the topics. This is a big crux of big chunk from GOC. What about IUPAC and isomerism? Not gonna do it because IUPAC nomenclature or isomerism takes entire one class. So I'm going to do that in the next session, which is going to happen on Friday. So do remember that today's class is going to be based upon all the topics that I said earlier. And share the session as soon as possible, as much as possible, and like the video as well. For those who are watching me for the first time, my name is Luv Mehan. Do follow my Telegram channel where I'll be putting up the PDF of this particular session. And apart from this, guys, you should also follow me on Unacademy @Luv Mehan. Okay? Yes. So do remember that. Okay? And yeah, over here, guys, you should remember there is one more Telegram channel that you actually have to follow, which is JEE English Unacademy, where physics and chemistry, both of these notifications are going to be available to you. And apart from this, guys, do remember that there is a crash course for advanced levels, for the advanced students, for the students who are actually going for advanced 2021, and for those who are really looking for complete syllabus coverage of class 12th. So I have started my own course where physical chemistry has been completed and inorganic chemistry will be completed by this month. And there are few more batches, new batches, which are teaching in English. The educators are teaching in English, and these batches are for 2023 and 2022 students. Which are these batches? Spark and the Shine batches, which have started in the month of August. And yahan pe you should remember that 2022 students, Unacademy is helping you to make your drop easy. If there's any dropper who's going to drop and going to give examination in 2022, USET examination is going to happen on 11th and 12th of September. And ultimately you should remember that over here, top first 1000 ranked students, rankers, are going to get scholarship up to 100%. So this is what is the biggest thing over here, because not just 3 students or 5 students will get good amount of scholarship. First 1000 rankers are going to get a good amount of scholarship. And hi to all the students who are just joining right now. We have Genius Yuva, Abhi, Riya. Share the session as much as possible, because I am not going to be giving you the one shots of organic chemistry again and again. It might happen few months later, not every day. So do remember this. And over here the pattern is going to be very much similar. There are going to be 90 questions, 180 minutes. JEE mains pattern is going to be there, and attempt and win scholarship worth rupees 1.6 crore. So this is the pool price. This is the actual price. 1.6 crore of scholarship is going to be given by Unacademy to the students who are actually going to enroll in this particular test and going to get first 1000 ranks. Apart from this, droppers, guys, whenever you're going to get scholarship, where will you learn? So we have a lot of batches. So we have leader batch, we have Drona batch, we have droppers to topper, Excel batch, Shine batch, and ultimately, which is the fastest batch? The batch which I am taking. These batches are starting right now. But if there's a student who has good amount of grip in chemistry and wants to cover up physical or inorganic chemistry within few weeks, maybe 2, maybe 3, just back-to-back sessions, then you can actually come to my batch, and over there you will be able to have all of it. Apart from this, scholarships, more scholarships for 2023 students. Over here, pay attention. Enrollment is free. The code that you have to use for unlocking any scholarship test is going to be Love Guru. So do write this code in the chat, LUVGURU, and over here you should again remember this happens every Sunday. 11 a.m. USET never happens every Sunday, but this combat happens every Sunday, and first rank 3 is going to get 100% scholarship, and rank 4 to 10 75, 50 and 25, so on till 51 to 150 rankers only. So do remember this. And what are the benefits whenever you learn in Unacademy? So over here in Unacademy, you get India's best educators, boys and girls. You get live interactive classes where you can ask doubts, PDFs, of the teachers. You get whatever they're teaching. Structured course is what you have. You always know when this course is going to over, and live test and quizzes happens every week, even in classes, so that you actually have good amount of problem solving skills. Apart from this, if you want Iconic, you'll get personal coach, study planner, study material, expert guidelines, and a lot of good features. So I do recommend 2022 students and droppers to go for 12 months, 2023 students to go for 24 months, and you should start. If there's any student who's looking to start their preparation online, let me know in the comment section, not in the chat section, in the comment section, and you can actually reach me out on my telegram channel, okay, or on Unacademy app. So do remember that. I'll help you, I'll guide you how you can actually get into Unacademy and start your preparation, which all batches are going to be good for you, and I'll give you mentorship as well. Okay? Hi Lakshika, welcome to the session. Amazing. Hi Akriti, hi JEE Mains. So where's your batch? So if you have to find my batch, you have to go to Unacademy, search Luv Mehan, go to my courses, and you will see course on solid state, course on coordination compound. You will see the name, as simple as that. See, ultimately, if I keep the name of my batch like rank 1 batch, so is it going to give you the rank 1? I mean, nothing is there in the name. It totally depends upon you. What are you going to become? My batch is going to help you. The name is as simple as course on solid state, the course on Falana Dhimkana chapter. Go through it. Okay? It becomes easier whenever you type, whenever you search solid state, metallurgy, whatever. Okay, so now we are starting up GOC, and we are getting into carbocations and carbanions. What exactly, when do they become carbocations or carbanions? We will talk about this as well. Now pay attention. Hi to Munazir, welcome to the session, watching from Kashmir, thank you. And yes, a very good evening. So guys, now pay attention. Whenever we talk about a carbocation, so what does a cation mean? First of all, cation means some species, some atom carrying a positive sign. When we talk about carbocation, it means the carbon having a positive sign. Guys, I'll take you to the basics. And I'll make you, go through each and every problem as well. So we are going to do problem solving as well. How many of you are ready for the problem solving? Let me know. And now guys, pay attention. What's going to happen? Carbon, when we talk about the Lewis dot structure, what is a Lewis dot structure? You make the symbol and you make the number of valence electrons. 1, 2, 3, 4. Why is that? Because carbon has an electronic configuration which is 1s2, 2s2, 2p2. So these four are the valence electrons. These are the 4 valence electrons. But what exactly happens when ultimately, let's say we have carbon attached with hydrogen, attached with R group, and attached with, let's say, one more R group. Okay? These are the alkyl groups. And over here it is attached with a halogen. Halogen is more electronegative, or carbon. Halogens are more electronegative is what we are going to consider. A quick test for you guys. What is the electronegativity of carbon in the Pauling scale? Let's see. Who's the genius over here? Yes, you do have to remember the values. You should be knowing the values. Let's see who's going to give me an answer. Pay attention. I'm going to give you something before we even get into the carbocation state. We have fluorine, we have oxygen, nitrogen, carbon, boron, beryllium, lithium. Then we have chlorine, bromine, and iodine. Let's talk about halogens and carbon. Okay, so fluorine has electronegativity 4, 3.5, 3.0, 2.5. 2.5 is the electronegativity of carbon. Akriti, 2.1 is for hydrogen. Do remember that. Okay, and now when we go down the group in the case of halogens, you can actually write it as 3.2, 3.0, 2.7. Can I say iodine as well is much more electronegative than carbon? This is 2.5, this is 2.7. All the halogens that you're looking at are electronegative than carbon. So what are they going to do? The bond between the carbon and the halogens is going to be polar. Carbon and the halogen X. There are going to be, let's say, 3 more bonds with hydrogen or carbons. We don't care about that right now. What exactly happens in the case? This is a covalent bond. This is the electron of carbon. This is the electron of halogen. Does halogen has more electrons? How many? 7 in total. So what exactly happens? Sometimes when this particular halogen wants 8 electrons, wants to become X minus, because in the case of X minus, the octet is complete. This anion is stable. What's going to happen? Both of these electrons are going to be taken up. These both electrons will go to the halogen. Will carbon, have a loss? Yes, carbon will experience a loss. This will become carbon positive with 3 bonds, and X, whichever minus is going to be there, it's going to be going like this. This is the 7th electron of halogen. This is the 8th electron of carbon. Yes, 8th electron got by the carbon. And now over here, how many bond pair do you see? There are only 3 bond pairs. How many lone pairs do you see on carbon? 0. The number of bond pairs plus the number of carbon, the lone pairs. What does it gives you? The number of hybridized orbitals. What is going to be the hybridization of carbon over here? The hybridization of the carbon is going to be sp2, spp, whatever, spp, spp, whatever, in whichever way you want to take. But yeah, 3 bond pairs, 0 lone pairs, spp. So sp2 is going to be the hybridization. And whenever we talk about the carbocation, what is going to be the shape when we talk about sp2? So this is going to be sp2, and for the shape, sp2, for the shape of the molecule is going to be near the central atom, it is going to be trigonal planar. What is it going to be? The trigonal planar. Sir, is this session for mains or advanced? This session is for mains, but anyhow this session will also help you in advance. It's nothing like that. But the reason I'm taking the session is for 2022 and for the 2023 students. So do remember this. Yes, amazing. This is what we're talking about. Then in the case of trigonal planar, what is going to be the bond angle, boys and girls? It's always going to be 120 degree, 120 degree, 120 degree. So do remember this, okay? So in mathematics you do that, right? These all 3 angles are same. Dash, double dash. And whenever we talk about which chapter, when we show congruency, it's been long, but yeah, are you guys getting it? These angles are same. And now let's talk about the stability. Whenever we talk about the stability, so whenever we have a carbocation, there is somebody who snatched away carbon's electron. Now carbon is sad, carbon is crying. Does carbon have friends? Yes, carbon has few friends. So let's say we have just one friend of carbon. Rest we have hydrogen and hydrogen. Why hydrogens are not much friendly with carbon? I mean, even they are there, but hydrogens are already having just one electron. And if hydrogen lose an electron, it doesn't really cry that much. But another carbon knows the pain. What if that would have happened to me? Right? Whenever we see somebody in pain, sometimes or the other we feel it, right? What if this would have happened to us? The same thing happens with the carbon. So what exactly happens? Carbon tries to provide some amount of electron density towards the carbocation. And what exactly happens? So ultimately this positive charge is available but in less amount. This positive charge is available but in less amount. So ultimately make a small positive sign. But then can I say this carbon is sharing up that positive charge? Because let's say this carbon lost 100 rupees. this carbon thought of paying him 20 rupees. Is he having a loss of 20 rupees because of this one? So he is not having a loss of 100 now, he's having a loss of 80. So they're sharing up the loss. They're sharing up the loss. Do write this down in the chat. And now you should write partial positive on this one. This is slightly going to be partial positive because they're sharing up the loss. Okay, so do remember this. But now when the these friends increases, instead of one more hydrogen, let's say we are having one more carbon, then is the loss going to be shared more? Even this carbon pays him 20 rupees. The amount that is lost by this carbon is going to be now 60. So again this decreases and partial positive character also comes on this carbon. Now pay attention. When one more hydrogen is getting replaced by the alkyl group, this is also going to have a partial positive one. This one is also paying up some amount. So ultimately when the loss was 100 rupees, this paid 20. So I'll do it minus 100 because minus why? Why is minus over here? Because it's a loss. But this one paid 20 rupees. So plus 20. But over here I'm going to write minus 20. Minus 20 plus 20. Minus 20 plus 20. What is the actual final loss for this carbon? Can we write it as minus 40? See, so this carbon is having a loss of minus 40. Rest everybody is having a loss of minus 20. So they shared. So that this carbon doesn't get much of scolding. Think of this carbon is having a strict parent, okay, and he actually lost 100 rupees. There could be a possibility that his parents are going to scold him too much. So what exactly happened? All the carbons shared some kind of loss with it. Is this clear? Yes or no? If it is clear, give me some smileys in the chat and let's move forward. Okay. And now over here, what is going to happen? So the stability of carbocation is maximum when there is 3 alkyl groups. That becomes 3 degree or tertiary carbocation. When we talk about 2 degree, that means only 2 alkyl groups, 1 hydrogen. And when we talk about 1 degree, that means 2 hydrogens but 1 alkyl group. So whatever the degree is, 3 means 3 alkyl groups, 2 means 2 alkyl groups, and 1 means 1 alkyl group. Clear, right? So do remember that. Now we are going to talk about carbanion. Carba means carbon. Anion is going to have a negative sign, negative charge. Okay. Now pay attention. So there was a carbon which had 4 bonds. Okay. The fourth one was with something like hydrogen, let's say. Okay. Over here there is an R group, there is an R group, there is an R group. Now what exactly happens? Pay attention. What if this hydrogen's electron is snatched away by the carbon? This hydrogen leaves as H plus. What is going to be the sign on the carbon because of that extra electron? It's going to be negative. Now let's look for how many electrons does carbon has and the bond pairs. So guys, carbon, its own electron, hydrogen's electron, bond pair, bond pair, bond pair. So we have 3 bond pairs and 1 lone pair. What is going to be the hybridization? The hybridization over here is going to be sp-p-p, sp3. And now what is going to be the shape? According to Vesper theory, lone pairs provide too much of repulsion. So anyhow, the hybridization that you guys are going to write is going to be sp3. But if you see the shape, pyramidal, trigonal pyramidal is going to be the shape, just like NH3. Correct? So now guys, pay attention. This is going to be a pyramidal shape and the hybridization is going to be sp3. And now guys, pay attention. Now this carbon snatched away the electron of hydrogen and hydrogen is crying. But did carbon cry? did carbon over here committed crime? Yes, for me it's a crime. You know, snatching away the electron is a crime. Okay. So now there is one alkyl group, there is another alkyl group, and there is a third alkyl group. Now guys, let me know, when this carbon snatched away the electron, does carbon realize that he has done something wrong? And does carbon also realize that it is so small, the carbon is so small that it cannot hide this extra, not electron, money in his house? Then carbon seeks help. Carbon asks other particular carbons to help him, but they do not help, because the carbons are like, we will not take this bad, you know, money from you. We are not going to do that. You do whatever you want. Instead, when these carbons got to know, they are trying this carbon to leave this money. How is that? So this carbon got 100 rupees from somewhere through some criminal activity. And now, but these carbons are trying to expose this carbon, that we will get you caught. We will get you caught. And how is it going to happen? These carbons, these alkyl groups always provides plus I effect. We will talk about this as well, the plus I effect. Okay, what is a plus I effect, inductive effect? We will talk. And then ultimately this negative sign, so ultimately it was 100 rupees that he snatched. This carbon is providing plus 20 rupees, this one is providing 20 rupees, and this carbon is providing also 20 rupees. So what exactly happens to this carbon? The money that he was trying to hide becomes so much that it comes, you know, in front of the police. Okay, and I will talk about what is going to be a police over here, who is going to be the policeman. But ultimately money is what? The electron, the charge, right? So instead of having a minus, just a minus charge, extra charge is going to be there. So always remember this. Pratham Bansal is saying, sir 96.8 पे worst rank क्या हो सकता है? नहीं पता. In an academic class, I do not care about ranks and percentile. I'm so sorry. I'm over here to try to teach other students who are anyhow sincere with their studies right now. I want everybody to focus over here. I'm not going to talk about any percentile or rank. I'm so sorry, because I do make shorts on this. Maybe you do not watch it. Now I cannot do anything about that. Let's move ahead. Over here, the stability. So if there is going to be one alkyl group, stability is going to be more. Why? Because if we have three alkyl groups, they are trying to expose more. If we have two alkyl groups, then ultimately there would be less exposure. When there is going to be just one alkyl group, just one. So just do remember this. The plus I effect decreases, and over here we are going to talk about the plus I effects. Okay? So is this really clear about what is a carbanion, what is a carbocation, and how the stability order is? Do you understand the stability order, boys and girls? Let me know. Come on, in the chat. Yes, don't worry Pratham, just be there in the Telegram channel and try to see a video where I'm talking about the percentiles and the NITs. Okay, so just watch that particular. It had been, I have uploaded this few days ago. And now let's talk about the order over here. So guys, you have to really let me know, what do you think and how do you think that the carbocations, see everywhere you can see a carbocation. This is the, and this is where we are going to talk about the resonance, the inductive effect, and a lot of things. And this is where we are going to dive much more deeper into the session. Okay, now let me know, which one do you think? Just put a guess. I'm not expecting you guys are already done with GOC. I'm expecting you can make silly mistakes as well, any rubbish mistake as well, but think about it. Soumitra says D. Okay, and anybody else? Why is this particular stability is going to be maximum in third, and then in first, and then in the case of second? Why is that gonna happen? Or could it be A as well? Because over here I see a pi bond, over here I see a single bond, and over here I see a lot of pi bonds in conjugation. And over here, if you would see, let's talk about this. So whenever we are going to talk about, give me a second. So over here, you should remember this first one is going to be the best. Second one is not going to be the best. Okay. So this is going to be good one, right? Because of the resonance. So do remember this. I'll talk about what is conjugation. So over here we are, whenever we are looking for resonance, we have to look for conjugation. Okay. What is resonance? For me, it's the musical chair. Or have you ever played musical chair or something like a game which is like something like I do not remember the name. You have to pass a particular, could be a pillow, could be a gift, could be anything in a birthday party where somebody will be playing up music, and if as soon as the music stops, whosoever is going to have that parcel or that packet in the hand, he or she gets out of the game. So that's how it is in the case of resonance as well. Okay, it's that same game. Over here, whenever we talk about the conjugation, the electrons, the pi electrons delocalize. The pi electrons change its position. We'll talk about that. Okay, so don't worry. What exactly happens over here, guys? I'll let you know. There is one electron. There is one electron. What is this particular carbon crying? Yes. What exactly happens? Both of these electrons will come over here. Where? Here. Will this electron cry now? No. But what about this carbon? This positive charge comes over here. As the pi bond moves over here, we'll talk about resonance. Again, don't worry. Over here, do not worry. There is one close friend. This is a close friend. That's the reason I have made double arrows. This is a far friend, this is the reason I have made a single arrow. So if this is a loss of 100 rupees, this is paying 20, this is paying 10. The far friend is paying, but paying less. Okay, so do remember that. And now let's talk about the last one. What exactly happens? You know what? I'm not just simply going to rush away to the next question or the theory. I am going to make you write the resonance hybrid of the third, ion. Okay, so let's write it. Pay attention. CH2, a positive sign. How many of you are great at, or how many of you have revised how to make these resonance hybrid structures? Let me know. Make it with me. So what exactly happens? Over here, this pi bond is in conjugation with positive sign, because there is the positive sign. Over here, there is no pi bond. This is the site. So now, guys, pay attention. This pi bond will come over here. A positive sign. A pi bond, a pi bond. Okay? And now, what exactly happens? This pi bond wants to come over here. Pi bonds are like that only. Now the pi bond came here, and there is going to be a positive sign over here. And then now, what's going to happen? This pi bond comes over here. Where will this positive sign go? I'll make it here. Pi bond here, because this one came here, and then the positive sign over here. Okay, and then see this. Now ultimately this pi bond wants to come here, and this positive sign will jump here. Very dirty, but yeah, I think it solves the purpose. Is this really clear to each and everybody? How to do this one? How many of you tried with me? How many of you really tried doing it with me? what exactly happened over here? Think about it. There was a loss of 100 rupees, right? These two carbons, this carbon actually gave entire 100 rupees to this and showed for few minutes that his 100 rupees is lost. The next carbon gave him 100 rupees and showed that he is the one who lost 100 rupees in actuality. And then similarly, the last carbon also showed that actually he lost the 100 rupees but nobody else. Okay? And then ultimately that 100 rupees loss is again back to the first carbon. How many carbons shared this positive sign? How many in actuality? 1, 2, 3 and 4. Turn by turn, right? So this is where they actually made things pretty much stable. And why stability actually happens if we make this positive sign jump or dance more? Because whenever we talk about stability, always remember that in order to have a good stability, you should remember that this positive sign should not be more. If I am going to have a great amount of loss, which I might not be able to hold or handle, then what's going to happen? You know, I'll cry. Okay, let's say I'll cry. But this is what you should remember. And then when somebody will see me crying, somebody can take, somebody can make fun of me. That is what negative signs, negative sign or anions do. They come and attack if the positive sign is going to be more and more. But as the positive sign has been shared among other carbons as well, then ultimately none of the carbon is actually feeling stress or burden. Okay, so do remember this. Sir, in the third structure, no pi bond on the top. Okay, my bad, I missed it. Correct, there has to be a pi bond. Amazing, Ria. Ria, is this clear for now? Shall we move ahead? Let me know. Okay, let's move ahead. And now over here, next question. A solution of -L, 1 chloro, 1 phenyl, ethane. So anyhow, you do know, I haven't taught you IUPAC nomenclature. For those who know it, make the structure. For those who do not, do it with me. Ethane, for ethane, there has to be 2 carbons. Eth is for 2. Ethane means, ane means alkane. 2 carbons. Phenyl group is C6H5, 1 hydrogen lesser than benzene ring. On the first carbon, we have the benzene ring, okay, something like this. And on the first carbon itself, we have chlorine, we have hydrogen, and we have 3 hydrogens over here. In toluene, racemizes slowly in the presence of a small amount of antimony pentachloride due to the formation of. So ultimately you should remember, what does this racemerization means? Come on, let me know. You should remember, whenever we talk about racemerizes, ultimately this is -L. Whenever we're talking about racemic mixture, it contains both the optical isomers, the D and the L. Over here it's only L. We started with pure, but ultimately later we are having both. Now what is going to happen? This only happens and only because of the carbocation formation. And how is this? Pay attention. So this is what I made. This is the first carbon, this is the second carbon. Phenyl group, which is actually the benzene ring -1 hydrogen. This is chloro, this one. Whenever we are using SbCl5, you should remember it is a halogen snatcher, just like AlCl3. This is a halogen snatcher. It takes the chlorine minus with it. one chlorine minus. From where? From here. These are the two electrons. This chlorine leaves with both of the electrons. So where will be the positive charge come? This is where the positive charge is going to be. And then what's going to be the scenario? There is the positive sign, right? But now whenever we talk about the positive sign, you tell me the hybridization. Hybridization over here comes out to be sp2, and earlier it was tetrahedral when it was sp3. Over here, whenever we talk about the carbocation, you should remember there is going to be hydrogen, there is going to be CH3, and there is going to be the pH. All these three groups, which all three groups? The hydrogen, the phenyl group, and the methyl group, all of these three are on a same plane, of paper, okay? And now whenever this chlorine minus is going to come back, so see, on a same plane there is methyl group, there is phenyl group, there is hydrogen, there is carbon. All four of them are on the same plane. Now whenever chlorine minus has to come, because chlorine minus will again get attracted towards the positive sign, then ultimately it can come from the front or it can come from the back, right? So that's what we're talking about. If it comes from front and from back, one of these is going to be the D, the other one is going to be the L, okay? So over here, chlorine is again going to get attached to the same carbon, but D and L mixture is going to be there. And when do we see D and L mixture? Whenever we talk about optical isomerism. And how many of you are there who does not know anything about optical isomerism? Let me know in the chat, because the next particular lecture is going to be upon optical isomerism. So do not miss that out as well. And now let's move ahead. In the following carbocation, hydrogen and methyl that is most likely to migrate to the positive charged carbon is going to be. Let's see how many of you would be able to give me the correct answer. Come on, let me know. Over here, do you see a carbocation? What is the degree of this carbocation? It's 2 degree. It's 2 degree. Okay. How is that? 1, 2. 2 direct carbons are attached, right? Is this carbon providing, inductive effect? Yes. Is this carbon providing inductive effect? Yes. Is this carbon providing inductive effect? Yes. Okay. This is an OH, so don't worry about this. And now, because we'll talk about OH as well, but what we are talking about is if this is the positive sign, where do you think a positive sign suits better? At a carbon or a hydrogen? Which is more electropositive? Hydrogen is more electropositive than carbon. And anyhow, in the whole chemistry, a lot of elements snatch hydrogen's electron and make it H+. So hydrogen has no problem with it. Now let me know which hydrogen will go to catch this positive sign. The fifth, the fourth, the third is here, second or first. Any guesses? Though I am in class 12th, my 11th is very weak. Don't worry, we'll make 11th class much better. And now over here, the correct answer to this question is D. So what's exactly happening over here? Whenever we're talking about hydrogen at carbon 2, what's with the carbon 2? The guys, pay attention. Do you see over here the carbon? Do you see the hydrogen over here? What's happening with this particular OH? That's the point. Now pay attention. Oxygen is partially negative. Okay, oxygen is partially negative, and you should remember, if this hydrogen goes over here and gets it, then ultimately you should remember this positive sign comes over here when hydrogen goes over there. It's going to be like something like this. The methyl group the carbon, the OH, carbon, hydrogen, hydrogen. This is going to have a positive sign. Carbon, hydrogen, methyl group, methyl group. Okay. Now, why is positive sign much more stable over here is the question. Because you should remember, oxygen over here is having 2 lone pairs. But also with the hydrogen it's partial positive and oxygen which is partially negative. And when we talk about the OH group, just because the oxygen's size is so small, having 2 lone pairs and some extra partial negative charge, can I say the oxygen over here is going to have inter-electronic repulsions? Yes. And those inter-electronic repulsions makes the oxygen donate some of the electron density. And what will happen over here? It will donate the electron density. So this is what you should remember, okay? Over here, these particular electrons, one of them is going to be partially donated. It will show resonance over there. Okay, the lone pair and the positive sign is going to have a resonance effect over there. Okay, and that is how the positive sign will go on oxygen for few seconds, for for very less time. Carbon is going to be free. Then again, what's going to happen? This pi bond can come back and the positive sign will go back. So they'll play, they'll pass this positive charge back and forth with each other. Do remember this. Okay, and now let's talk about another question. The correct stability order of the following species. Where do you think the positive charge is going to be the most stable? Let's see. So over here, I can clearly see there are options where we see oxygens as well. Right? Here there is no oxygen, there is no oxygen. Now pay attention. Whenever we talk about this carbon, there I can see 2 inductive effects. Wherever I see this carbocation, I see 1 inductive effect. What about this one? 1 inductive effect and 1 could be a resonance, right? Over here, a resonance could be there, but I see 2 inductive effects. Compared to both of these, which is much better? First is better than third, correct? When we compare both of these, which one is better? Second is going to be better than fourth. What about the third and the second one? The third and the second one. You should remember, guys, it's all about 2 inductive effect and 1 inductive effect and 1 resonance effect. You should remember, resonance effect is much more stronger than the inductive effect. Okay, resonance effect is much more stronger than the inductive effect. So hence, the correct answer to this question comes out to be 1, 3, 2, 4. Okay? Yes? And now let's move ahead, and we are talking about the inductive effect, the groups that you have to remember, which is having stronger effect, which is having a weaker effect. The groups which is going to have more negative charge, but they cannot handle it, will try to give these electrons, share these electrons. O minus. Why O minus is the one which is having the highest? I'll tell you. Because oxygen is very small. Oxygen has its own lone pairs. This is the shared electron with carbon, let's say. Okay. And over here, you should remember this is the electron of oxygen again. But this electron is the snatched one. This is providing the negative sign. But this extra electron with the other 6, 1, 2, 3, 4, 5, 6, experiences a lot of inter-electronic repulsions. And whenever repulsion happens, what exactly oxygen minus does? It provides the inductive effect. It shares very small amount of electron density with the carbon, with the neighboring carbon. So do remember this, okay? But why then carbon OO minus does slightly less? Pay attention. Whenever we talk about carbon attached to a carbon, and this carbon over here is having a double bond O and oxygen with a negative sign. So this oxygen with a negative sign, will it try to provide, give this electron to somebody else? Yes. Now see what exactly happens. This electron is provided between oxygen and carbon. What will happen to this? This becomes a pi bond. How many bonds of carbon do you see? This carbon. How many bonds do you see? 1, 2, 3, 4, 5. There are 5 bonds. Does carbon can make 5 bonds? No. So one of the bonds over here comes here, pi bonds, and ultimately that becomes a negative sign. So that negative sign is shared by 2 oxygens. This negative sign is shared by 2 oxygens. But still, when these 2 oxygens are talking to each other, what are they really talking about? They're really talking about, it's very hard for me and for you to keep this extra electron. Though we took it from somebody, but it's hard because of our small size. What can we do? They ask this carbon for help. This carbon says, don't worry. From you, I'll take some amount of electron density and I'll give it over there to the neighboring carbon. And this is how this group COO minus group provides inductive effect, shares some amount of electron density. Is this clear? Let me know. And now over here, what are we really looking at? We're looking at the carbon which is having 3 friends. Let's say this carbon has a close friend which is having a positive sign. This carbon is crying. This carbon says, don't worry, I'm your closest friend. I'll help you out. But this carbon had 3 more close friends. So anyhow, this carbon is going to help. But also, these 3 methyl groups, alkyl groups, will also take part. And hence, the amount of electron density this carbon is providing is going to be amazing. That's the reason we see the inductive effect when there are 3 methyl groups. It's amazing. When the number of alkyl groups, methyl groups are decreasing, ultimately it's becoming lesser and lesser. What's with this? When we're talking about this one, the methyl group, we're actually talking about the same carbon having hydrogen. How many? 3. This carbon does not have any close friends. But will this carbon still help the carbon with a positive sign? Yes. But where do you think the help would be better? When there are no carbon as friends, or where there are 3 more carbons as friends? You let me know. Option A is going to provide better inductive effect, or option B? I am sure you have got the point. See, do as teamwork. Absolutely correct, Deepak Singh. Absolutely correct. Right? So do remember this. This is what they're doing, teamwork. Here, teamwork, the team member, teamwork is happening. Team member is less. Team member is less. There is no team. There's just one man army. Okay. So do remember that. And now, whenever we talk about the minus I groups, these are the ones which are greedy, which wants electrons to get, inside their atom. They want the electron density. So guys, let's talk about the most, dangerous one. Nitrogen, when it is attached to a carbon, nitrogen is anyhow electronegative than carbon. Nitrogen itself will take electrons from carbon no matter what. Now nitrogen is attached to a fluorine. What will fluorine do to nitrogen? Same thing. What nitrogen is doing to the carbon. Right? Let's put one more fluorine. Fluorine is doing the same thing. 3 fluorines are making nitrogen cry. Nitrogen says, I don't care about who else is going to cry. He snatches electrons from carbon. the electron density. But you know what makes things worse? Nitrogen is electronegative. But how many bonds do you see on nitrogen right now? 4. Can nitrogen make 4 bonds? It can only make 4 bonds when nitrogen's lone pair is donated. Nitrogen's lone pair, hai na? So ultimately, do you see a positive sign over here? Yes. So what is exactly happening over here? Over here, you should remember there is a fluorine taking up electrons and nitrogen having a positive sign. When nitrogen, see, nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. When we're talking about nitrogen having 1 less electron, the positive sign, then it has 4 electrons. So all the 4 electrons making 1 sigma bond. And that's how you see that ultimately nitrogen is having a positive sign and 3 fluorines snatching away from the electron. Nitrogen becomes crazy. Nitrogen is very angry right now. And nitrogen puts all the anger on carbon. Because this is what people do, right? Whenever they are actually feeling very bad or they are angry or they are irritated, they try to suppress somebody else. I mean, which is a bad thing, right? So do remember that. Poor carbon is getting suffered. And that's the reason NF3 plus is showing the maximum minus I effect. But which all groups, which all functional groups do you should remember the most? So I'll mark this for you. Okay? So ultimately NO2 is important, CF3 is important, aldehyde is important, and then OH is important. And if you would see halogens, it's very much simple. Higher the electronegativity, higher is the minus I effect. Fluorine, chlorine, bromine, iodine. Can you see that? You should know the reason. Higher the electronegativity, higher is going to be the minus I effect, is what you have to remember. Okay, so do remember this. Now, when we talk about the inductive effects, the minus I or the plus I, these are the permanent effects. So they stay in the molecule as it is. So if there is a carbon, CH3, and there is carbon, double bond O, O minus, what are you going to look at? So ultimately this one is trying to provide a minus I, plus I effect over here. This is trying to provide a plus I effect over here. So do remember this. This happens all the time. This happens all the time. Now, inductive effect decreases with the distance. How is that? The close friend, you know, the next friend, the far friend, and so on. Let's say this particular carbon is having a loss. There is going to be a carbon, there is going to be a carbon, there is going to be a carbon. This is the close friend helping too much. This is a friend helping slightly less. Is this a friend? Yes, but a far friend. So that's the reason I'm making the number of arrows different. If you can see, the closest one is helping the most. If there is a loss of 100 rupees, it's a minus 100. This is paying 20 rupees. This is paying 10 rupees. This one is paying 5 rupees. Cool? Yes or no? Do you also do that? If your close friend is going to be in need, or maybe your crush is going to be in need and she needs a pen in the examination, you'll give it right away, right? But if there is going to be a friend of yours which is not a good friend, but yeah, just a friend, you may or may not help him. That's how the things are happening actually over here. Okay, and now let's talk about the plus I effect and the minus I effects application. So guys, pay attention. Whenever we talk about the carbocation, stability of carbocation increases with the plus I effect, and stability of carbanion decreases. And when we talk about the minus I effect, the stability of carbanion decreases and stability of carbanion increases and the stability of carbocation decreases. Do remember this. And why is that happening? We saw it, right? When there was a positive sign on the carbon, other carbons were helping it because of the plus I effect. And when there is, let's say, guys, let me know which is going to be much more stable, carbon with a negative sign. Okay, there is one fluorine, one fluorine, one fluorine, and there's one more carbon anion, but with CH3, CH3, CH3. A or B, which is more stable? Come on, boys and girls, which is more stable? Yes or no? Which is more stable, boys and girls? B is more stable according to Deepak. So this is what exactly happens when students join in the middle. I'll tell you, A is going to be much more stable. Correct. Why is that? Because this negative sign is carried by carbon. This carbon doesn't want this negative sign because of the small size, inter-electronic repulsions, and many more reasons. Fluorines help it. Fluorine says, give it to us. We'll keep it. We'll keep a lot of electron density with us. Over here, they are saying, no, you take it from me. What's going to happen because of the plus I effect? This carbon, the negative sign on the carbon will increase. Inter-electronic repulsions. Repulsions between electrons is going to increase. Over here, the negative sign decreases. Wherever the charge decreases, things become stable. Where the charge increases, things becomes unstable. That is what we are talking about in the second line. Minus I effect stabilizes the carbon ion, and plus I effect destabilizes the carbon ion. Do remember this. Okay, amazing. That's so good to see Deepak is taking my jokes lightly. Yes, don't mind. It's just, no offense. Which of the following is correct with respect to minus I effect of the substituents? Minus I effect. What do you think? Where do you think? Which one of them is going to be having the correct order? We're looking for minus I effect. And the correct answer to this question is absolutely A. So what are we really looking at? Just pay attention, boys and girls. So when we are comparing, see, nitrogen, oxygen and fluorine. In all these scenarios, you should remember fluorine is the most electronegative one, and we are talking about snatching it away. Fluorine is having the maximum amount of pull. Why is that? Because fluorine is alone. This is electron of carbon. This is fluorine's electron. When we talk about oxygen, R group, methyl, ethyl, propyl, whatever, they themselves provide the plus I effect. Oxygen is greedy, but this greed has been, satisfied by a plus R effect. So ultimately there is going to be a carbon, but the minus I effect is going to be slightly less. But when we talk about NH2, what's the scenario? Pay attention. Nitrogen is having two hydrogens, and hydrogens are very much electropositive when compared to nitrogen. And this nitrogen anyhow is having too much electron richness. It's electron rich, and again no need of much of electrons. So yes, there is going to be a minus I effect. If this is attached to a carbon, there will be, but over here it's going to be more. And in the case of fluorine, see, no bonds, right? Nobody is helping, neither hydrogens, neither alkyl groups. Fluorine is going to be like, I am only going to snatch it away from you. If there wouldn't be this R group, then oxygen will also be becoming, taking up good amount of electron density. But R group is helping. Hydrogens are helping. to satisfy these electronegative elements greads. Okay, do remember that. Minus I is directly proportional to the electronegative. Yes, in a general way, you can definitely remember this. It will always help. And now let's talk about the next one. The stability of carbanions in the following. There is a minus sign, there is a minus sign, there is a minus sign, and there is a minus sign. And see, first and the foremost difference that you should look at is that the carbon over here is sp2 hybridized, sp3 hybridized. The carbon over here is sp2 hybridized, and the carbon over here is sp hybridized. And you should remember, carbon with sp, carbon with sp2, and the carbon with sp3 hybridization. This is the trend, but this trend is of what? Electronegativity. So now what do you think? A carbon with sp3, as it is less electronegative than the carbon of sp, where do you think the negative sign is going to be held stronger? Where carbon can say, it's not making me destabilized, I'm loving it, I am going to keep it to myself. Where do you think? There only the stability is going to be the best. There itself the stability is going to be the best. So do you teach in Hindi on any platforms? Yes, I do teach in Hindi on Unacademy Plus. I do teach in English as well. So do remember to see my lectures on Unacademy platform, special classes as well as plus classes. Boys and girls, let me know. What do you think? The negative sign is going to be much more stable when the carbon is sp, then slightly less stable when it is sp2, then slightly less stable when it is sp3 hybridized. Then what about the the negative sign on the phenyl group, the benzene ring? Over here, the correct answer to this question is C. C. First, because of too much electronegativity, then over here we have second, then third, and then fourth. That's how we are going through. Because ultimately you can also remember, over here what you see is the bond order 1, bond order 2, bond order over here is going to be 1.5, and over here it's 3. And when we are talking about the hybridizations, you should remember that this particular, the negative sign on the benzene ring is going to be stable, but slightly less stable than the first one. Hi Captain. Amazing. Welcome to the session. Thank you so much, Abhi. Now let's move ahead. Over here, let's talk about the next one. Correct order of increasing strength of the compounds. Acidic strength. Acidic strength means these hydrogens will go. These hydrogens will go, and then what we are talking about is higher the for stable the conjugate base is. Conjugate base is better is the acidic strength. Do remember this. Stable the conjugate base is, better is the acidic strength. And how is this going? You know what is going to happen over here, guys? Pay attention. If I have carbon double bond O, O minus, if I hide this negative sign, then H plus will not come back. When the negative sign present over here is going to be less. If I add a carbon with 3 fluorines, then what will happen? Minus I effect. Carbon will pull from here, and this negative sign is going to be less. This negative sign will decrease over here. Hence, hydrogen plus will stay much more longer away from the conjugate base. And the, for much more, if the hydrogen plus stays much more longer for the away from the conjugate base, the acidic strength is going to be better. Is this clear? Okay, boys and girls, let me know. भैया please teach in Hindi, you will get more. ठीक है. Anyhow, there are a lot of students who do not have any option if they have to learn JEE, if they have to learn chemistry for JEE. So that's the reason I am teaching students in English as well. You have many Hindi channels. Absolutely correct. You have a lot of Hindi channels, right? Amazing. Yes, don't worry Vidya, I'm going to teach in English only. And right now, pay attention boys and girls. If we do not want this hydrogen plus to come, just look for which groups makes the negative sign go lower and lower. Now let's look into that. Guys, pay attention. What exactly this group is doing? This is providing plus I effect. This group destabilizes the conjugate base. What about this one? Minus I effect into 3. This one can be the best. When we talk about this group, plus I effect. Which one is going to make destabilized conjugate base more? Carbon with 2 methyl groups or just a single carbon? Here the teamwork is more. Stability over here is going to be less. Stability over here is going to be less, but I made double arrow over here. Okay, I made single arrow over here. Stability over here is going to be super duper better because of the minus I effects. My bad, minus I effects. And when we talk about this one, guys, pay attention. Carbon double bond O minus, then we have a carbon CH2, then we have oxygen, then we have a methyl group. What did we see about this particular group? OR. Does it shows minus I effect? Right? This shows some amount of minus I effect, correct? Stability is going to be good. But the best stability is what you can see in the case of C. First is going to be C, let's write. Then it is going to be B. Oh, my bad. C, then it is going to be B. Then it is going to be A, and then it is going to be D. Yes, D, A, B, C. That's the correct answer. I watched you first time. So your teaching style is amazing. Thank you so much, Deepak. If possible, if you are really liking it, do share my videos among your friends. Maybe they will like it, and maybe even if it makes it easier for them, it would be of great help to them, right? Now, pay attention boys and girls, we're talking about the basic characters of amines. Similarly, whatever we have seen till now is what we are going to talk about. Okay? So now, how do you think that amines, hydrocarbons with NH2 group, let's talk about, or NH group or N group. Okay? So this is going to, the basic structure is going to be like R group attached to NH2. This is primary amine. Why is that primary? Why 1 degree? Guys, pay attention. I told you, right, how to see it? Because there is just one alkyl group. When we talk about a 2 degree, this is 2 degree because of 2 alkyl groups. When we talk about a 3 degree amine, tertiary amine, then there would be three alkyl groups, right? So do remember this, and this is how we are going to compare. But I'm going to ask you something. In which type of amine, 3 degree, 2 degree or 1 degree, the plus I effect is going to be more? Think about it. The plus I effect is going to be more. I'll also tell you how you can remember how, why amine is, or why ammonia is having basic character. Pay attention. Guys, there's one definition that you should remember. Base is the substance that captures, this is my definition, okay, captures H plus. Okay, whichever thing can capture H plus, that is going to be a base. It can be a conjugate base, it could be a base. When we talk about, and in the case of Lewis base, when we talk about Lewis base, there's one more definition. The molecule which is having electron rich, if the central atom is electron rich and having good amount of electron density, if it can donate its lone pair. I'll talk about this. See, which is more electronegative? Nitrogen with electronegative value 3, hydrogen with 2.1. Nitrogen is more electronegative. Partial positive, partial positive, partial positive. What about nitrogen? Partially negative. But apart from this, the lone pair. Let's count the valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. The octet of nitrogen is complete. So right now nitrogen is having 8 electrons. Apart from that, extra, these electrons of hydrogens are slightly closer to the nitrogen. So nitrogen is going to experience higher inter-electronic repulsions. Guys, I've been saying this word a lot of times. Is this clear to you guys? What is inter-electronic repulsions? Thank you so much, Vidya. Sir, I have a doubt in 7 p.m. class. Are you going to start from the basics, sir? Yes. See, in the 7 p.m. class, we are going to have question solving. But I'm going to give you the solution of those questions from the basics. So don't worry. Just solve all the questions, okay, with me. Even if it is becoming tough for you, still be there, because I'm going to teach you how to approach a question, how to tackle a question, how to solve it, everything. Okay? Yes. Now guys, pay attention. Over here, what exactly happens as the inter-electronic repulsions are higher? The central atom would be like, oh god, there are so many electrons fighting with each other. There's so much of fight between electrons. Let me just temporarily give this electron to somebody, this lone pair. And if there is H plus available, guys, how much electrons does hydrogen plus has? 0. But how many electrons does hydrogen require to become stable? Stability will come when it will acquire helium gas configuration, electronic configuration. Hydrogen will become stable when it occupies 1s2, which is according to the duplet rule. Nitrogen gets stabilized with the octet rule, hydrogen needs duplet. These two electrons are given to H plus. Now, will the hydrogen have a positive sign? No, because hydrogen got electrons. The one who left electrons is going to have the positive sign. So nitrogen gave electrons to hydrogen, 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 hydrogen. Positive sign is going to be on nitrogen. This is the ammonium ion, NH4 plus. And now guys, pay attention. Hey Tarun, what happened? Welcome to the session. So take my name. Okay. Okay. Now pay attention. Over here, where do you think is this NH3 going to be much more basic, or this one? Which is more basic according to you? Here there is no plus I effect. Here, R group provides plus I effect. I mean, in comparison with hydrogens, we do not really care about whether they provide plus I effects or not. Let's talk about the R group. It is definitely going to provide the plus I effect, correct? What will happen to the electron density over here? See, partially positive, partially positive, partially negative. Can I say this partially positive negative character is going to be more over here? All because of the plus I effect, right? And as the plus I effect is more, partially negative character is more, this nitrogen will sooner, now much more frequently, much more easily will provide this lone pair to H plus. Correct? Yes or no, boys and girls? and this is where this particular, the B, the primary amine, is better than the A in terms of basic strength. B is more basic than A. Primary amine is going to be more basic than the ammonia. This is what we are going to see. Primary amine is going to be more basic than ammonia. But this is what we are talking about in the gaseous phase. Do remember this. And why is that? I will talk about that as well. Over here, guys, pay attention. Higher the plus I effect, better is the base. Higher the plus I effect, better is the base. Then lower the plus I effect, the plus I effect is becoming lower. The basic strength becomes lower. No plus I effect, basic strength is neutral. What about aniline? Guys, I'm talking about aniline. What is aniline? Lone pair on NH, a nitrogen. Are you ready for the resonance hybrid? Let's do this. Whenever the NH2 group is attached to the phenyl group, NH2 phenyl, okay? Lone pairs are donated. Nitrogen, what does nitrogen wants? The lone pairs to be donated. It donates inside the molecule. Positive sign on nitrogen, double bond, because those lone pairs became the pi bond over here. When the pi bond forms here, this pi bond comes over here, because one carbon cannot have 5 bonds. 1, 2, 3, 4, and not the 5th one. That's the reason this pi bond comes over here and becomes a negative sign. Now pay attention. Now this negative sign wants to come over here and this pi bond comes over here. Right? And now what exactly happens? This negative sign wants to come over here, this pi bond comes over here. Negative sign. Now remember, this negative sign comes over here to become a pi bond, and this pi bond comes over here. Is this clear? So now let me know, is this lone pair at any point of time available for an H plus, outer H plus to grab? Can any outer H plus grab these lone pairs? No, right? Because out of there is the lone pair 1, 2, 3, 4, and there it is. Out of 4 cases, there is only just one time where the lone pair is freely available. Right? So out of 4 seconds, only for 1 second this lone pair is available. Do you think that is it easy for an H plus to get these lone pairs, or it is tough? It's actually tough, right? That's the reason this lone pair is not readily available. This lone pair is not readily available, and hence the basic strength becomes way much poor. Then we have NH3, where at least there is no plus I effect, but lone pair is available, freely available. Then we have 1 plus I effect, second and third, but this trend does not carry in aqueous phase. Whenever we're talking about these amines or ammonia in water, this does not happen. Why is that? We're talking about 2 degree is better than 1 degree is better than 3 degree. 3 degree, which was best in gaseous phase, is now not great in the case of aqueous phase. And why is that? Guys, because when we are talking about 3 degree, this is the lone pair. It is making 2 degree. and then when we are making 1 degree, pay attention. Clear? You're getting the difference? Now pay attention. What is exactly happening over here is these groups are bulkier. These are bulky groups. Bulky groups. Over here bulkiness is less, bulkiness is more, bulkiness is super more. So when there is an H plus which thinks of approaching nitrogen, it cannot approach. From here it cannot approach. From here it cannot approach. It has only one site to go from. In this case it cannot go from here, it can go from here, it can go from here. Correct? From here it can go from here, it can go from here, it can go from here, it can go from here. The H plus, right? What's changing? The crowdiness. Over here the crowdiness is known as steric hindrance. Steric hindrance is less, which is a better thing for reactivity. Steric hindrance is more. Steric hindrance is super duper more. But in this case plus I effect is less. Here plus I effect is more, steric hindrance is comparatively less. Plus I effect is good, steric hindrance is okay. Here plus I effect is more, but steric hindrance, see, it's too much. Here steric hindrance is less, but plus I effect very less. This is a sweet spot. This one is a sweet spot where this is a perfect balance of steric hindrance and plus I effect. And this is where secondary amine, give me a second, is going to be having a better basic character than first degree, because steric hindrance there should be a possibility for H plus to reach, and then we have third degree amine and then the NH3. So do remember this, okay? And now we are going to talk about resonance. So what exactly happens in the case of resonance? It's the delocalization. Delocalization means ringa ringa roses, okay, of electron cloud. Because electrons, to be very honest, nobody should say electron is just a particle. That's the reason I was never talking about donating up electrons whenever we were talking about plus I or the minus I effect. I talked about electron density, some part of electron. It's the electron cloud actually. So do you see the electron cloud over here? Extra of the pi bonds, pi. But do you see over here? Now the locations have changed. How does that happen? One pi bond becomes a negative sign over here. Then this negative sign wants to become a pi bond over here. Then this pi bond comes over here. This pi bond comes over here, and this is how the location changes. Ultimately, how do we make it? Instead of making alternate double bonds, single bonds are made. And what are we trying to show over here? Partial double bond for all the carbons. This is double, this is single, double, single, double, single. But on the other end, single, double, single, double, single, double. So on an average, each carbon bond is having a bond order which is 1.5. Partial double bond, correct? And single bond are shown to you. Partial double bond are shown with these dashed lines made as a circle. Do remember this. Okay? Cool? Guys, pay attention. Vidya, thank you so much for all your blessings and so much love. Are you getting it? Let me know. Over here, we are going to look for the conjugation. So guys, whenever we talk about the conjugation, pay attention. Whenever we talk about conjugation, we are looking for pi electrons. So the pi and the pi electrons should be on the alternate sides. They should not be like this. Carbon, 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 carbon. Okay? Pi bonds should not be, this is not conjugation. When double bonds are on the, this is site 1, this is site 2, should not be on the adjacent sites. They should be on the alternate sides. Something like site number 1 is having a double bond, site number 2 is not having, site number 3 is having the double bond, site number 4 is not having. Correct? So there should be an alternate position. There should be some gap. Similarly over here, site number 1, 2 is empty, site number 2, 3, site number 4 is empty, site number 5, site number 6 is empty, right? Not empty, single bond is there, but I'm talking about pi bonds. Okay? So do remember this. When alternate sites is going to have pi bonds, then we are going to talk about pi-pi conjugation. And this is very much available in benzene as well. Site number 1, nothing over here. Yes, nothing. Yes, nothing. When I say nothing, I'm talking about no pi bonds. Okay, no pi electrons. So do remember this. This is conjugation, and benzene has a good amount of conjugation. Then now we are talking about the another conjugated structure, but with a positive sign. I'll tell you how. Pay attention. Again, how to see it? Positive sign, nothing. Single bond is nothing. Okay. Wow, something is there. Extra. Something extra. Something extra. Which all sides are left? This side, this side, this side. You see, if you see sites where only single bond is present, alternate single sites are having alternate sites are having single bond, it's having conjugation. Do remember this. Something like this. Okay, it's very easy to see a conjugation. Now pay attention. Positive sign, single bond, so nothing over here. I see pi electrons. Alternate sites is having plus sign and the pi electrons. Is it having conjugation? Yes, it is having conjugation. Both the electrons jump from here to here. This one lost its electron, positive sign. So sometimes this carbon is holding loss, sometimes this carbon is holding loss, and then ultimately two carbons are sharing up the loss, and the positive, this positive sign, the carbocation is stabilized. And now pay attention. We're talking about the negative charge conjugation with a pi electron. How is it? Negative sign site, nothing over here, pi electrons, nothing over here, pi electrons. Do you see alternate sites having these charges and pi electrons? Yes, that's how it is going to be. What exactly happened? The negative sign becomes a pi bond. This pi bond becomes a negative sign. This negative sign again wants to become a pi bond. This pi bond becomes a negative sign. Right? Pay attention. Ultimately, when the pi bond becomes a negative sign, it came over here. Now guys, do let me know how many carbons did participate in order to hide these electrons, this negative sign. Let me know how many how many carbons participated to hide this one electron, one extra negative charge. Three carbons. First one, second one, and the third one. So do remember this. Okay. Now let's talk about the lone pair and the pi electrons conjugation. Do you see a lone pair at site number 1? Here you see nothing, just a single bond. Here do you see a pi bond? Yes, it's under conjugation. The pi bonds are going to form negative. Pi bonds just behave like negative charge. Pi bond keh raha hu. Lone pairs are going to become a pi bond. Yes, the lone pairs do behave like a negative charge. Whosoever donated got a positive sign, and this pi bond came over here. So what's the scenario? A negative sign. Can something like this also happen? Pay attention. That this pi bond goes over here. Then what will happen? Pay attention. Can this happen? And also a negative sign will come over here, and a positive sign will come over here. Can this happen? No. Why is that? Because nitrogen is having how many bonds over here? 1, 2, 3 and 4. Apart from this a lone pair, apart from this a negative sign. Nitrogen can never do that. So many electrons, and technically when it is carrying, see how many? oh, 2 bonds over here, 2 bonds over here, and lone pair, it's very tough. It's not going to happen. The hybrid, it is not having these D subshells, I mean D orbitals, and apart from this, the negative sign and the lone pairs can't stay together. The negative sign and the lone pairs will never stay together. So do remember this. Okay. Now let's talk about the radical one. So guys, pay attention. What exactly happens? This is a radical. This is an unpaired electron. Neither a positive sign, neither a negative sign. It's neutral. This particular site is neutral. Only the unpaired electron is there. What exactly happens? Do you see an electron over here and an electron over here? This is going to show you the homolytic cleavage of pi bonds. Homolytic means one electron stays here itself, one comes up over here. This one also comes up over here. When one electron is going to be here and one more over here, what's going to happen between both? It's going to be a bond. That's what happened. The electron that came back to the carbon, it's this one. So can we say the radical also is resonating with the pi bond? If only if there is conjugation. Yes. Do you see conjugation? See, over here is a radical. Only a single bond over here. Pi bonds over here. Yes. Alternate site. One, nothing, and then. It's very easy to identify conjugation. Do remember this. And when we talk about the plus R groups, the ones which are actually going to take provide electrons very much easily through resonance. So oxygen provides its lone pair. Oxygen provides its lone pair. Oxygen provides its lone pair. Nitrogen provides its lone pair. These are actually providing lone pairs. Okay. When we're talking about the minus R effect, carbon double bond O H, what's going to happen? This oxygen takes up the lone pair or this pi bond. Okay, na? So it takes up the pi bond and then it's showing you the minus R effect. Same is here. NO2 is a very special case. NO2 is a very special case. Let's do this. I'm going to show you how NO2 makes resonance hybrid. I'm going to just show you the first step, then later you know it. For those students who are actually watching the session since starting, pay attention. When we talk about the NO2 group, it's like this. Nitrogen, double bond O, O. This is a single bond, this is a sigma bond, pi bond, and this is sigma, but a coordinate dative bond. Okay. What exactly happens? One of the pi bonds are taken up by the oxygen. And then if this particular pi bond will be taken up by the oxygen, this becomes a negative sign on the oxygen. And then you should remember nitrogen is right now having just 3 bonds. Nitrogen will have a positive sign. But nitrogen does not want a positive sign. This pi bond comes over here. When this pi bond comes over here, carbon says I'll hold the positive sign, because oxygen is going to cry when it is going to hold a positive sign. Then nitrogen will cry slightly less, but yes. Why will they cry? Why did I say they'll cry? Because those are electronegative, right? And now a positive sign over here, and then pi bond will jump. Positive sign over here, and then this pi bond will come over here. This positive sign will go. Something like this. I missed the double bond over here, but yeah. And then this pi bond comes over here. Chalo bhaiya. Nitrogen gets its positive sign, and as soon as the positive sign comes over here, negative sign jumps back. So this is how it is going to be. Okay, do remember this. It's very important to know the resonance hybrid of NO2 group on benzene, phenyl group, and COOH as well. These are the two important ones, is what you should remember. And now, which amongst the following is the strongest acid? Again the same thing. What are we really looking at? we're looking at hydrogen, 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 and here as well. Something is different with CN. See, bromine, iodine, chlorine, they all are going to show you the minus I effect. Can CN show you any other effect? Guys, pay attention. Carbon with hydrogen. Carbon triple bond N. Do you see conjugation? If this hydrogen leaves as H plus and the carbon is going to have a minus sign, this negative sign, does it has conjugation? Yes. This is one side. Alternate sides are having no pi bonds. Pi bond, pi bond, pi bond. What type of group the CN is? It's the minus R effect. There are three minus R effects which are going to take this negative sign, and ultimately the ones which is going to have a minus R effect is going to be the correct answer. Minus R effect stabilizes acids, plus R effect stabilizes bases. Stability of bases decreases, stability of acids decreases. Do remember this. It's going to be helpful. And now over here, next question, which of the following molecule is least resonance stabilized? Least resonance stabilized. Wherever you see there is no aromaticity, the conjugation breaks, there only you will have least resonance stabilization. Guys, pay attention over here. There are three bonds, correct? Conjugation, alternate sides. What's happening over here? 1, 2, 3. Again there's conjugation. Guys, pay attention. This is the lone pair. Nothing over here, no, nothing on the side. Then on the alternate sides you have the pi bonds. Amazing. And these pi bonds are also on the alternate side because nothing is over here. Correct? Amazing. Now let's look into the D option. A pi bond, nothing, a pi bond. Amazing. Nothing, a pi bond. Amazing. Nothing, nothing. There should be something, right? There's no conjugation over here. Is this clear? Is it C? No, that's not C. That's actually going to be D. Do remember that, because there is no complete conjugation when we talk about D option. Okay, in the ring formation, every or A, B, and C is having complete resonance inside, but D is not having it. Do remember this. D over here is non-aromatic. And now we are actually diving. Are we going to talk about how to find aromaticity, non-aromaticity, anti-aromaticity? What do you think? Are we going to do that? Yes. So we will talk about that. Okay. So now guys, let me know over here, which of the following is not a resonance structure of the other? Let me know. How would you find? Over here guys, pay attention. Let's start with something. Let's start from here. If the negative sign comes over here, this will come over here as a negative sign. This will become a pi bond. This pi bond becomes a negative sign. Something like this. This became a pi bond. Pi bond became a negative sign. So these C and A are a resonance structure to each other. Then can I say this negative sign can come over here and this pi bond can come over here as a negative sign? Pi bond became negative sign became a pi bond. Amazing, right? Why do we think that the negative sign from here will jump over here? No reason. D is going to be the correct answer. D is going to be the correct answer. Okay, is this clear? And now let's move ahead. We're talking about the hyperconjugation. So for the hyperconjugation, you should remember, let's say, taking up an example, carbon is having a positive sign. It is having one hydrogen, second hydrogen. Somebody took its electrons. Okay, there is one more carbon with hydrogen, hydrogen, hydrogen. Now whenever we have a carbon with a functional group with a positive sign, adjacent to that, this carbon, this closest friend, is an alpha carbon always. And these hydrogens are always alpha hydrogens. For hyperconjugation to occur, alpha hydrogens should be available. Okay, and now guys pay attention. What exactly happens? This carbon is crying. Why? No, one electron is missing and 3 bonds. What exactly happens? This is a sigma bond. This sigma bond is having electron over here and electron over here. This carbon says, let me help my friend. Can you manage? Hydrogen says yes, no issues. This electron and this electron, both of them are brought here. Both of these electrons are brought here, and ultimately they are made, removed from hydrogen, they are made pi bond. What about this positive sign? Now is this carbon having a loss of electron? No. Who's having the loss of electron? Hydrogen. Right? So there is a pi bond. There was a sigma bond earlier. It was a sigma bond over here with the hydrogen alpha hydrogen, but now it's a pi bond. So do remember this. The electrons which were actually participating as sigma bond now gets into the empty p orbital of carbon. So do remember this. This becomes a pi bond. Now what can exactly happen? Pay attention. This bond can come over here. This bond can come over here. Can be like this. And the positive sign can go back. But ultimately it will not happen until this happens. So this particular bond comes over here. This positive sign is shared with the another hydrogen. Higher the number of alpha hydrogen, longer this positive sign is going to be away from the carbon. Do remember this. And ultimately again this positive sign is going to be shared by this hydrogen, and when this is done, then only the positive sign will come to the carbon. So higher the number of alpha hydrogen, higher is going to be the stability of carbocations. Okay, do remember this. Amazing. So now alpha carbon should be sp3 hybridized. Alpha carbon should be sp3 hybridized. It should have 3 sigma bonds. Okay, and yes, at least one sp2 hybridized carbon. Which is the one? This is the one. At least one alpha hydrogen should be there to sacrifice. If there is no alpha hydrogen, hyperconjugation will not happen. If it is 1, it's good. If it is 2, amazing. If it is 3, super duper good. Can there be 4, 5 or 6 alpha hydrogens? Can there be 4, 5 or 6 alpha hydrogens? Let me know. Yes. How is that? A carbon with a positive sign. Do you see alpha hydrogens over here? This is alpha carbon. Alpha hydrogens are 3 over here. This is also alpha carbon. Do you see alpha hydrogens to be 6? Right? If I can make one more alpha carbon, these hydrogens are also alpha hydrogens. So do remember, a carbocation at max can have 9 alpha hydrogens if it is a tertiary carbocation, and the carbons are all the adjacent carbons, alpha carbons are sp3 hybridized. Do remember that. Okay, and those should be obviously the methyl groups. These alkyl groups should be the methyl groups. Okay, so do remember that. Amazing. Example, yes, this is what I'm telling you. This is a sigma bond. It became a pi bond over here. One hydrogen is left. Then again another hydrogen will share it, the positive sign, and then the next one. So higher the number of alpha hydrogens, the positive sign stays away from the carbon. Do remember this. Okay, and now we are going to talk about the aromaticity. So whenever we are talking about the aromatic compounds, they should be cyclic. There should be a cycle. There should be a ring. Okay, this should be cyclic, planar. They should be on same plane, same piece of paper. Conjugated. I am not going to teach you again what is conjugation, what is conjugated, but this is very much important. The number of electrons should be 4n plus 2 electrons. Okay, so put the value of n is equals to 1. It gives you 6. pi electrons. And do you see in the case of benzene, how many pi electrons do we have? 1, 2, 3, 4, 5 and 6, right? So is benzene going to be aromatic? Yes. Is it on the same plane? Yes. Is it cyclic? Yes. Also one more thing, carbons should be, all the carbons should be sp2 hybridized. All the carbons forming up the cycle, the ring should be sp2 hybridized. Do remember this. And now let's talk about more. Over here guys, pay attention. Cyclic, planar, conjugated with 4n pi electrons. Not 4n plus 2, 4n electrons. Just remember 4n. Whatever electrons that we are counting is going to be pi electrons only. Prerequisites for understanding periodic classification, please say. Prerequisites to understand periodic classification is going to be atomic structure. You should know Aufbau's rule, Aufbau's principle, Hund's rule, how to write electronic configuration. You should also know what are atomic numbers or what are atomic masses. These are the things that you should know. Okay? Then only you will be able to identify and differentiate between elements. So do remember that. Okay? Now do you see 4n plus pi electrons? 4n pi electrons? Yes. 1, 2, 3, 4. When we keep n is equals to 1. 1, 2, 3, 4. Why didn't I count this? Because ultimately at once only one lone pair is going to participate. So obviously we just have to count just one. Again, yes. Again, yes. So do remember all of these things, okay? Do remember all of these things. And now when we are talking about non-aromatic, pay attention. If you see any carbon which is sp3, it's not going to be aromatic or anti-aromatic. It's going to be non-aromatic or non-planar. If you see with any number of pi electrons, you simply do not have to calculate the pi electrons. Just see if it is non-planar or see if it is having sp3 hybridization. So when the number of carbons becomes so many, this is non-planar actually. This is something like this. It's not actually planar. Okay, so do remember this. This is how it is. Okay. What about this one? This is again negative sign. So 4n, 1, 2, 3, 4. 4 electrons. What about this? 4n plus 2. Keep the n value 0. You'll get 2 electrons, pi electrons. This is aromatic. Okay, so now let's talk about something else. Why is this non-aromatic, boys and girls? Can you let me know? This looks planar. Why is this non-aromatic? All because of conjugation is not present. It is a sp3 hybridized carbon. Whenever you see an sp3 hybridized carbon, it's going to be non-aromatic. Okay, and any other non-aromatic? No. Yeah, so do remember that. Give me a second. Wait a minute. This one over here, guys, pay attention. There should be a pi bond though. It's a misreading. I mean, it's a some mistake over here. If there is a pi bond, it is aromatic. If it is like this, it should be non-aromatic. So I'll make it correct. This should be like this. Do you want to know how many pi electrons are there? Pay attention. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons that we are talking about. What could be the value of n to make it 10? Just put the value of n is equals to 2. 8 plus 2, 10. 10 electrons. This has 10, 4n plus 2 pi electrons. Okay, which is 10. Right? Mass number, atomic number, yes, absolutely correct. Let's talk about something else. So I'm going to do some correction. Now let me know. Which of the following is not aromatic? Not aromatic means not anti, non-aromatic. Okay, anti nahi पूछ रहे. Talking about non-aromatic. Which one of them? Just look for something that I told you. Not aromatic. Come on, come on, come on. Okay, anyhow, I'll let you know. The correct answer to this question is B. Why is that? Because though it is cyclic, but as there is nothing over here, this particular compound is not planar. This compound is not planar over here. Okay, this is actually going to have, a different shape. Identify the molecules whether they are aromatic, anti-aromatic, and non-aromatic. Let me know. So we'll do it. Together. Pay attention. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I see sp3. I have marked it. Over here you should remember that there is a positive sign, there is a positive sign. Correct? There is no conjugation. sp3, 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 sp3. 1, 2, 3, 4, 5, 6, 7 and 8. 8 means 4n. Correct? The last one is going to be anti-aromatic. Yes. See, this one over here, because of sp3 carbons, non-aromatic. 3, 4, 5, 6. Aromatic. 1, 2, 3, 4. Anti-aromatic. We cannot count plus sign as an electron, right? Don't worry about that. Okay? Do remember this. Yes or no? Amazing, right? Compare the stability of the following carbocations. Pay attention. So do you see conjugation over here? Higher the conjugation, better it is going to be the stability. Pi bond, nothing. Good. There is conjugation. But with only one pi bond. Over here, the conjugation is between the two pi bonds, and the conjugation is there between the plus and the pi bonds. And now what about over here? Conjugation is there with the positive sign, right? But now there is oxygen as well. Let's see. The correct answer to this question is going to be C. And why is that? Because the first one over here, whatever you see, is non-aromatic. And why is that? Though the conjugation is there, but it's very small. sp3 hybridized carbons are there. The second one is the anti-aromatic. And why is that? Only 4n pi electrons. But when we talk about the third one, 1, 2, 3, 4, 5 and 6. The last one is going to be the aromatic ones. And whenever we talk about the stability, aromatic ones are the best, then we have non-aromatic, then we have anti-aromatic ones have the least amount of stability. So if you would just simply go for the number of is there a good amount of conjugation, this logic will actually take you. The reason I'm telling you this is because when I was a kid, when I was a student like you, and when I was not ready with this aromaticity topic, I used to think this way. So don't do that. So offline classes are started. I have whole backlog in chemistry. Half 11 has passed. What should I do? I'll make a video for that. I'll make a short video for that. Half of the chemistry of class 11th has passed. Okay, I'll do that. Okay? Don't worry. I'll definitely make a video today itself for you. Now, determine the order of stability of the following resonating structures. We are going to look for the stability. Okay, there's a lone pair, conjugation is there. There is a positive sign on nitrogen. Okay, ठीक है. And the negative signs are, and positive sign are way much here and there. Where do you think? See, ultimately I'll tell you something. If a molecule we can keep it neutral, it's good. All of them are neutral, but if there is going to be negative and a positive sign available, obviously some nucleophile or electrophile will come and attack. So over here the correct answer to this question is A. No charges, that is the most stable one. And when we talk about in the case where the charges are going to be actually very much closer, that's what we're talking about. Charge separation reduces stability of the resonating structure. So if the charges are going to be way much far away from each other, the stability is going to be lesser and lesser, is what you have to remember. Thank you so much, Vidya. Love you too. Over here, now let's talk about the next one. In which of the following compounds resonance does not take place? It does not take place over here. Conjugation is here. Conjugation is also here. Conjugation is here. Where do you see there is no conjugation? Okay. Yes. Give me a second. Yes. Okay. Conjugation is here. Let's not talk about this because anyhow they are going to have some resonance. But when we talk about when we are talking about the structure to be, non-aromatic over here, ultimately as it is not planar, because these resonance happens when the structure is planar. Wherever the planarity is going to be missing, the resonance is not going to be available, and this is where it is. So do remember this, okay? Yes. Let's move ahead. 3 resonating structures of alkyl cyanate is given. Okay, so there is R, alkyl group, nitrogen, carbon, oxygen. There is a positive sign and a negative sign. There is a negative sign and a positive sign. Stability. See, stability of the first one is going to be the best. Why is that? No charge separation. When we talk about a positive sign on nitrogen or a positive sign on oxygen, which is much better? A positive sign on nitrogen is much better because nitrogen is more electropositive than oxygen. Oxygen is more electronegative, so it should carry a negative sign. That's what we are going to look at. So yes, first is the most stable one because of the no charge separation. Then even if there is a charge, nitrogen should carry a positive sign, not oxygen. Second and then third, because in the third case oxygen is carrying a positive sign, is what you should remember. Okay, and now which of the following alkene hyperconjugation does not takes place? Think about it. Come on. Come on, boys and girls, let me know. Over here, the correct answer to this question is D. And why is that? Because this is the alpha carbon, this is the alpha carbon, but there is no alpha hydrogen. Why is that? This is methyl group, methyl group, methyl group, methyl group, methyl group, methyl group. There's no hydrogen available. And this is where we are absolutely at the end of this class. So do remember that we are going to be doing up more and more of these classes where I'll be bringing up organic chemistry for you. We'll be covering up organic chemistry so that things becomes easier for you. But make sure that from the next time as well, you guys are actually very much pumped up, very much aware of the sessions and the timings. But anyhow, we will be keeping up these sessions in the evening only. And by now, do remember that today we are going to have, at 6 p.m. It's 6 p.m. right now. Yavar sir is going to be starting up its class. So do check his class and watch till the end. And my class again is going to happen at 9, where we are going to start with the chemical bonding. So we'll meet in the night as well, at night at 9 p.m. But right now, do not miss Yavar sir's class, which is going to happen at 6. All the best. Take care. Stay safe, boys and girls. And let's meet again. Tata. Bye-bye.